Hello, this is session 5.3. We're going to solve the system of linear equation using elimination method. For the last two lectures, we've been solving system of linear equation using graphing and substitution. So this is the last method. First, objective 1. Using the equation 2x plus 3y equal 8. And then we want to test order pair 1, 2 is the solution of the given equation. In order to do so, all we have to do is plug in the order pairs to see if the left-hand side equal to the right-hand side, right? So I have the left-hand side is 2x plus 3y. X is 1 and y is 2, right? This is my x, this is my y. Well, 2 times 1 is 2, plus 3 times 2 is 8. So yes, it is equal to 8, which is equal to the right-hand side. So we conclude that the order pair 1, 2 is the solution of the equation 2x plus 3y equal 8. Next, multiply both sides of the given equation by 4 is the order pair 1, 2 is solution to this equation. So they ask us to multiply the given equation by 4. That means, let me rewrite the equation here. I got 2x plus 3y equal 8. And what I want to do, I want to multiply it by 4. You can put it in the front or in the back, doesn't matter. That means you distribute the 4 into each of the term. Distribute the 4 into each of the term. So now I have my new equation, which is ax plus 12y equal 4 times 8 is 32. And now I want to check if the order pair 1, 2 is still the solution of this equation. So now I'm going to plug in 1 for x and 2 for y. 1, 2. 8 times 1 is 1, 12 times 2 is 24. 8 plus 24 is 22. So check. So even though if we multiply both sides by 4, the order pair 1, 2 is still solution of the equivalent equation. Right? Multiply both sides of the given equation by -1. Now instead of multiply by 4, they ask us to multiply the above equation by -1. Now we're going to distribute the -1 into each of these terms. So I got the equivalent equation, -2x minus 3y equal -8. And then I want to plug in 1, 2 into the new equation to see if it equal to -8. So again, x is 1 and y is 2. -2 times 1 is -2, minus 3 times 2 is 6. So -2 minus 6 is -8. So yes, right? Well, so far so good. So far we've been multiplying the equation by a different number, positive number and negative number. The solution pairs does not change. Add the equation from part B and C, and then check if the order pair 1, 2 is still the solution. So the equation from part B is, let me highlight in green here. This is the new equation when we multiply by 4 in part B. And this is the equation when we multiply by -1 in part C. They want us to add those two together. So let me rewrite it here. Let me just copy those down. So ax plus 12y equal 32. And then from part C, I have -2x minus 3y equal -8. And then we're going to add them. We're going to add them together, term by term. We're going to add down. We're going to add down. So ax minus 2x is 6x. Remember, you add like term, right? You're going to add like term. We're going to add down. 12y minus 3y is 9y. Positive 9y plus 9y. 32 minus 8 is 24. And now we're gonna plug in x equal 1 and y equal 2 into this new equation. So this is the new equation here. And I'm gonna plug in 1 for x, 2 for y to see if it equals to 24, which is the right-hand side. Right? 6 plus 18, 9 times 2 is 18. 6 plus 18, it is 24. So check. Check. So the answer is yes. Is the last part, does multiply an equation by constant change the solution to an equation? Well, no, right? We've been multiply both side by 4, multiply both side by -1, and we even add the equation together, the solution does not change. So no. Basically, when you multiply an equation by a number, you get a new equivalent number. I'm sorry, a new equivalent equation. We're not gonna do you try one. Now we're going to solve the system of equation using elimination. And here's the step. So first step, we want to write both equation in standard form. You need to write the both equations in the form ax plus by equals c. If you have any fraction, make sure you clear the fraction by multiply through by the LCD. The second step is make the coefficient of one variable opposite. Remember, the method is called elimination. So you're going to eliminate one of the variable, right? Pick your favorite, either x or y, it doesn't matter. But in order to eliminate the coefficient, the variable, the coefficient of that variable has to be opposite, right? Opposite, they cancel themselves out, right? So make the coefficient of one variable opposite. Let me highlight that part. Decide which variable to eliminate, then multiply one or both equation by a number so that the coefficient of the variable are opposite. Add the equation. Once you multiply the equation by the number, whatever number you choose, depending on what variable you decide to eliminate, we want to add the equation together. Just add down like we did in objective 1. This should result in an equation with one variable. Once you add the equations together, you should come down to one equation with one variable. If you still have two variables, something wrong. Go back and do it again. Number 4, you solve the equation from step 3. And once you have one variable with one equation, you solve that to find the, and then you get the value. Once you get the values, you plug it back. You substitute the value from step 4 into one of the original equation and solve. And number 6, write the answer in order pair. Number 7, check the answer by substitute into both of the original equations. So let me demonstrate you with some problem. Maybe you'll make it clearer. Okay, so I have a system of equation. Now, the first step is make sure you check both equation in the form ax plus by equals c. Right, so as I can see, my two equation here, they both in that form, right? X and y is on the left, and then the coefficient and the number on the right. So I'm good. Ax plus by equals c. Now I'm going to pick. I'm gonna pick y to eliminate. I'm going to eliminate y. Why do I choose y? Because look at that. In the top equation, I got positive 1y. In the bottom equation, I got negative 1y. This opposite, right? Positive 1, negative 1, they're opposite. So once I add them, y will be gone, right? If I add them down, let's see, 2x plus 1x here is 3x. And y is gone. Positive y, negative y is gone. 5 plus 4 is 9. So 3x equal 9. Now I have one equation with one variable, right? I can solve this. All I have to do is divide both sides by 3. And now x equal 3. X is equal 3. Once I have X, I'm gonna plug it. I'm gonna plug the value X equal 3 back into one of the original equations. Pick one, doesn't matter which one. But I'm going to pick the second one because it looks simpler. I'm going to plug it back in here into this equation. So this one, I have X minus Y equal 4, X is 3, so 3 minus Y equal 4. Let me make the 3 in red. That's my X. Okay. Add 3. I'm sorry, subtract 3. So I'm trying to solve for Y here. That's gone. Now negative Y equal 4 minus 3 is 1. Divide both sides by -1 or multiply both sides by -1. I have Y equal -1. So the answer is 3 comma -1. Now let's check. I'm gonna check. Check in black. I'll check. Let me rewrite the system equation. I have 2 X plus 1Y equal 5. And then I got what? I got X. Oops. Maybe replace that with the parenthesis. X minus Y equal 4. Well, I don't know if it equal or not, so I'm gonna put a question mark there. And plug in the value. I have what? Negative X is 3, Y -1. See what happened. Okay. The first equation, 2 times 3 is 6, minus 1. So 6 minus 1 is 5. So yes, 5, it is equal to 5. And then 3 in the bottom equation, I have 3 minus 1, so that means 3 plus 1, so which is 4, which is equal to the right-hand side. So they both checks. It had to be both. If one of the equation is not checked, then that's not the solution. Something wrong. Okay, both have to be checked. All right, for the next for the next problem, I'm going to solve using elimination, but I'm not going to check. You can check it yourself. Okay, so solve by elimination. Again, I'm going to decide to eliminate variable y. Why do I choose y? Look, because I have negative 6y in the bottom. Let me highlight it in green here. I have negative 6y in the bottom. In order to eliminate variable y, the negative 6y, I need positive 6y, right? The opposite, they cancel themselves out. On the top, I got negative 2y. So all I have to do is make that negative 2 into a positive 6. How do I do that? Multiply the top equation by negative 3. By negative 3. Because negative 3 times negative 2 is positive 6. Okay, so let's do that. Now I have a new equation. Let's see. On the top, I got negative 3 times 3x is negative 9x. Make sure you multiply that negative 3 into everyone. Okay, everyone. Negative 3 times negative 2 is positive 6y. And then negative 3 times negative 2 is positive 6 on the right-hand side. Rewrite the second equation. Rewrite the bottom equation. 5x minus 6y equal 10. And now we're going to add. Look at that. The y is gone, right? Y is gone. Negative 9x plus 5x is negative 4x. 6 plus 10 is 16. Divide both sides by negative 4, I have x equal negative 4. Again, once I have the value of the one variable, I'm going to plug that value back into one of the equation to solve for the remainder. So I'm going to plug in x equal negative 4 into the bottom equation. Somebody else could have picked the top. It doesn't matter. The reason I picked the bottom because it's right. It's convenient in terms of writing. Okay, so this become 5 times negative 4 minus 6y equal 10. 5 times negative 4 is negative 20. Add 20 both sides. That's gone. I have negative 6y equal 30, divide both sides by negative 6. I got y equal negative 5. So the solution is negative 4, negative 5. And you can check it yourself. Okay. Again, you plug into both equations to check. If you not feel up to it, you can use decimals, but at least know how to check, okay? Because on the exam, they'll ask you to check by hand. You won't be able to use a computer to check. Decimal on the computer to check. But while you're doing homework, you can check with decimal. All right, the last one. The last one, it doesn't matter which one you choose to eliminate now because oh wait, let me say something about problem B. The reason I choose Y because it's convenient. Say somebody else choose to eliminate X. Or again, I'm talking about problem B still. If someone else choose to eliminate X, then they have to multiply the top bottom by what? By 5, right? Because let me highlight in blue here. I'll highlight in black here. I have 3x on the top and 5x on the bottom. I need to make these what? Opposites, right? So the LCD here is 15. So on the top, I need 15x. On the bottom, I need negative 15x, or vice versa, doesn't matter. So on the top, if you want 15x, then you have to multiply that equation, the top equation, by 5, and you have to multiply the bottom equation by negative 3. Right? So it's a small work, right? You have to multiply both equations by the number. So it's more work compared to just eliminate y. I only had to do one. Okay, for problem C, it doesn't matter now. I got what? 6x on the top, 5x on the bottom. And then for the y term, I got 5y on the top, 3y on the bottom. Again, I'm going to choose y here because it seems like the value is smaller. All right, I got 5y. I got 5y on top, and then 3y on the bottom. The LCD is 15, right? It's 15. Say I want 15y on the top and then negative 15y on the bottom. If I want 15y on the top, then I have to multiply the top equation by 3. And if I want negative 15y on the bottom, I need to multiply the bottom equation by negative 5. Because 3 times 5y on the top, I got 15y. And the bottom, negative 5 times positive 3y is negative 15y. Okay, so now my new equation, my new equivalent equations will be 3 times 6x is 18x plus 15y equal 13 times 3 is 39. And then on the bottom, negative 5 times 5x is negative 25x minus 15y equal negative 25. And now you add. Again, if the math doesn't work out, you have to do it again, okay? Because at the end, you should have one variable, one equation. 18x minus 25x, that's negative 7x. Negative 7x. Y is canceled. It has to be. If it not, then go back and do it again. 39 minus 25. 39 minus 25 is 14. Divide both sides by negative 7, x equal negative 2. Yeah, I'll write out loud. Negative 7, that's gone. So x equal negative 2. And again, you can plug in x equal negative 2 into one of the original, right? Original. By the way, it doesn't matter. You could have picked here. You could have picked this one. You could have picked this one, or this one, or this one. Doesn't matter, right? They all equivalent equations. But I'm going to plug into the original because it looks smaller. The value looks smaller. So I'm going to plug in x equal negative 2 into the bottom equation. Again, convenient. Somebody else could have picked the top equation. So the 5, oops, here, I use blue. 5 times x now is -2 plus 3y equal 5. 5 times -2 is -10 plus 3y equal 5. Add 10 both sides. Let's cancel. So I have 3y equal 15. Divide both sides by 3y equal 5. So I got -2, 5. You know what? Let me check. Let me check it with you using decimal to see for giggle, right? So again, you can check using just plug in -2, 5 into the original. But I'm going to use decimals here. 6y plus 5y equal 13. Six y plus 5y equal 13, and then let's see the the bottom equation. 5x plus 3y equal 5. 5x plus, oh, that's supposed to be plus, come on, 3y equal 5. Right here, this is where the blue meets. Oops, something wrong. 6y plus, oh, 6x. 6x. There you go. -2, 5. That's where the two line meet. That's your equation. Right? If you would have graphed this, the solution should be -2, 5. So it checked. We're gonna skip you try 2. Number 3, solve system by elimination. So here we have fraction. I don't know about you, but whenever we have fraction, I recommend you that you try to eliminate the denominator, right? Remember in the step 2, let me go back up here. Step 2 right here, clear fraction by multiply through by the LCD if you have fractions. So let me rewrite the system equation here. X plus 1/2 y equal 3/2. And then I have the bottom one is 1/5 x minus 1/5 y equal 3. Okay. Let's do the top first. The top, I want to eliminate that 2 in the bottom there. Well, the LCD will be what? 2, right? So I need to multiply both sides by, or I need to multiply every one by 2/1, right? 2/1, 2/1, 2/1. So let's see. So 2x, let me rewrite 2x. 2/1 times 1/2 is canceled, it's just plus y. 2 cancels, it's just 3. The bottom one, the LCD will be 5, right? LCD will be 5. So multiply everybody by 5/1. 5/1. 5/1. 5/1 times 1/5, that's just x, minus y equal 3 times 5 is 15. Okay, look at that. We eliminate the denominator. And now I'm going to choose y to eliminate because it's already opposite. I have positive 1y on the top and negative 1y on the bottom. So now all I have to do is add them up, right? Term by term. 2x plus 1x is 3x. 3 plus 15 is 18. Divide both sides by 3x equals 6. And you can plug 6 back into one of the original problem. Again, you can plug it back into the original here, or even here or here, right? They all equivalent. They all equivalent. Remember what we did in objective 1, the very first problems. We multiply both sides by a number, and that does not change the solution, right? So if I was you, or if I was me, I'm gonna pick this equation right here. I'm gonna pick this one. It looks like the simplest one. There is, right? So let me delete all these. I'm gonna pick the x minus y equal 15 to plug it back in, plug it back in there. Now I got 6 is for x minus y, minus y equal 15. Minus 6 both sides, subtract 6 both sides. That's gone. So I have negative y equal 15 minus 6 is 9. Divide both sides by negative 1 or multiply both sides by negative 1, y equal negative 9. So the solution is 6 comma negative 9. Again, so you can check that by using decimals. All right, part B, we're gonna solve the system equation using elimination, and at the end, we need to answer another question, which what conclusion can you draw? Okay, so I'm gonna multiply the top by 2, right? Because it looks like I want to eliminate x by 2. So now I got equivalent equations. 2 times 11 is 22x. Yeah, 22x minus 24y equal negative 90. And then rewrite the bottom one, negative 20. Can't write number 2. Negative 22x plus 24y equal positive 90. And then add them up. Positive 22x and negative 22x cancel. Negative 24y and positive 24y cancel. Negative 90, positive 90 also cancel. Okay, so on the left hand side, I got 0. And on the right hand side, I got 0. So 0 equals 0. This is true. This is true. Because it's true what? What do we say when we have a true identity? Do you remember just like in regular equation? What happened when we have a identity? Is all real solutions. So that means all real numbers. Or you can answer or let's see, or somebody could have put a script R. I'll accept that answer. Maybe I'll box my answer. Or somebody can say, or somebody can write as interval notation, negative infinity to positive infinity. Right, I'll accept all 3. Box in red. I'll accept one of those 3. Okay. Unless it's specified otherwise, I'll accept one of those 3. Don't give me all 3, just one. Just one. All right, part C. I'm gonna multiply the top by 3. If you do enough of these problems, you kind of know what to multiply in the first glance. So now I have equivalent equations. I got negative 9x plus 6y equal 8. And then rewrite the bottom one. I have 9x minus 6y equal 13. Add them together. That's cancel. So on the left hand side, I got 0. On the right hand side, 8 plus 13, that's 31 or 21, right? That's 21. Oh, I'm sorry. 8 times 3 is 24. I forgot to multiply. By the way, that's a very common mistake. Forgot to multiply the constant by the multiple. So 24 plus 13, that's 37. Well, 0 is definitely not equal to 37. This is false statement. When we have a false statement, there's no solution. No solution. I accept this answer, or if someone want to be fancy and use that math notation, that means empty set. 0 with a cross, empty set. Again, just give me one. Now, the objective 2 is solving application. Josie wants to make 10 pounds of trail mix using nuts and raisin, and she wants the total cost of the trail mix to be $54. Nuts cost $6 per pound and raisin cost $3 per pound. The system below model the problem. There's where N represent the numbers of pounds of nuts and R represent the number of pounds of raisin. How many pounds of nuts should she use and how many pounds of raisin should she use? So the first, so they give us the system equation, which is nice, but we need to know what that means. Right? I got the first equation, which is N plus R equal 10. Remember, N is the number of pounds, N is the number of pounds of nuts, and R represent the number of pounds of raisin. Right? Josie wants to make 10 pounds, so N plus R equal 10. Right? That's pretty straightforward. The second one, 6N plus 3R equal 54. Why is that? Let me highlight in blue here. Well, the nuts cost $6 per pound, and then the raisin is $3 per pound. So 6N plus 3R, and she wants the total cost to be $54. So 6N plus 3R must be equal to 54. And now we solve. I would recommend you eliminate R. Doesn't matter if you want to choose N. So multiply the top bottom by -3. Let me rewrite the system of equation here. Oops, it's supposed to be if and only if. 3N plus 3R equal 30. Oops, minus, I'm so sorry, minus. It's supposed to be minus. And then rewrite the bottom one, 6N plus 3R equal 54. And then add them together. This is gone. I have 3N equal -30 plus 54 is 24. Divide both sides by 3, N equal 8 pounds. 8 pounds. Now we solve for R. Now we can solve. So I'm going to substitute 8 into the very top equation. So I have N plus R equal 10. N is 8 plus R equal 10. Subtract 8 both sides. R equal 2 pounds. So 8 pounds of nuts and then 2 pounds of raisin. You can check by plugging 8 and 2 into the system equation above. All right, number 5. Andrea is buying some new shirts and sweaters. She is able to buy these 3 shirts and 2 sweaters for $114, or she is able to buy 2 shirts and 4 sweaters for $164. How much does it cost? First of all, you need to define the variable. Please, on the exam, define the variable. I don't want you to lose silly points. So what do they add? They add for the cost of each thing that she buy, right? So let X be the cost of 1 shirt. And then let Y be the cost of 1 sweater. Okay. Okay, so for the first scenario, if she buy 3 shirts and 2 sweater, it'll cost her $114. So 3 shirt, 3x, right? It could actually be the cost of the 1 shirt. So 3 shirt, cancel, plus 2 sweaters, so 2y equal $114. And then the second scenario where she buy 2 shirts, so 2x, and then 4 sweaters, so plus 4y, it'll cost her $164. And now we saw the system of equation. Again, I'm going to choose y to eliminate because all I have to do is multiply the top by -2. If somebody else would have picked X to eliminate, then they have to multiply the top by 2 and the bottom by -3. So that means you have to do it twice. Right? If you choose Y, then maybe just do it 1. So -2 times 3x is -6x minus 4y equal -228. We write the bottom one, 2x plus 4y equal 164. Add them together, gone. -6x plus 2x is -4x equal 4. 10 minus 6 is 4, 6. 164. Oh, 64, I'm so sorry, 64. Divide both, -64. Divide both sides by 4 by -4, x equal 24 divided by 4 is $16. So a shirt cost her $16. And then plug it back into the original. Plug it back into, I'll plug it back into the bottom because it's easier for me to write. Yeah, plug it back in there. So I got 2 times 16 plus 4y equal 164. 2 times 16, that's 32, plus 4y equal 164. Subtract 32 is, so 4y equal 132. Divide both sides by 4, y equals, see, 13 divided by 4 is 3, 12 divided by 4 is $33. So it costs her, one sweater costs $33. The last objective, choose the most convenient method to solve system equation. So for part A, maybe pause the video a little bit and try to answer this question on your own before I actually give you the answer. Okay, so for part A, I claim that I'm gonna use the substitution. Now, it's nothing wrong if you use elimination, unless it specifies otherwise, right? If they say use any method you want, then you go ahead, use any method you want, even graphing. But I would avoid graphing because sometimes if you have a fraction solution, it's not very wise to use graphing method. So I claim that I'm going to use the substitution method will be the most convenient because what? Y, the coefficient of y, the coefficient of y is 1, right? All I have to do is move that -4x to the right hand side, then I'm done, right? And I can just substitute into the top equation. So the first equation, I use substitution. Now somebody else can argue with me, I prefer elimination, and which is fine. If it was up to me, I would have used elimination too. But usually when you see y that have the coefficient of 1 or x have the coefficient of 1, substitution is recommended. For the second, for problem B, definitely recommend elimination. Because the coefficient of each variable is not 1, right? If you use substitution, you have to divide both sides by some number, and that'll give you fraction, which we're trying to avoid, right? So elimination is the absolute recommendation. Where 6A, somebody else can do elimination or substitution. I don't think that's a big deal, but preferably substitution. All right, that's it for the session, for section 5.3. Good luck on doing your homework and see you on Monday.